Hi guys, how we doing? I'm just going to have a go at recording this second video for you guys now. So what we're going to look at in this session is the UK's changing coastlines. Before we do this, what I'd like to do is just have a think about really what we're going to try and get done in this session, and that is essentially look at the key types of coastal habitat that exist in the UK. And then what we're going to do is start to discuss the physical processes affecting these habitats with a case study that I'm going to work through with you shortly. Okay, so what I'd like to do to start with though is just pause the video at this point, and I'd like to list the key types of coastal habitat found in the UK. So, for example, sandy beaches, and you might think of some others as well, so hopefully you can come up with a list of a good number. And then what I'd like you to do for each of the habitat types that you think of is give it a location where you can find these particular habitats. So that can be locally, or it could be further afield, if you can think of examples. Okay, so pause the video now and have a go at that. Okay, so hopefully you've had a go at that. Let's have a look at some answers. Okay, so here's the ones that I came up with. So these, you might have come up with others that aren't on this list, but these are the ones that are listed on the specification. So we do need to cover these. So what we have are sand dunes, and these are pictured in the top left-hand corner. Salt marshes, estuaries. So estuary, here an example I've given is Plymouth Sound, where rivers meet the sea. Sea cliffs, and the sea cliffs pictured here in Cornwall. And you can see some interesting features on the sea cliffs. For example, the arch that you can see possibly just there on this island there. You've got sandy beaches and rocky shores. Wave cut platforms, and we're going to have a look at wave cut platforms in a minute. And there's one in the right hand corner there, and this is a wave cut platform that's been cut into a cliff here, and we're going to have a look at how that forms and why that forms in the way it does. Islands, again, we talked about kind of islands there in the sea cliffs that we can see in the bottom left hand corner. Mud flats and deltas, and these are kind of shown here on the middle right hand picture. And these are where you have rivers that are tidal, and when the tide goes out, it leaves behind mud flats, and these are quite important habitats for some bird species. Lagoons and shingle, and there's a shingle beach in the bottom right hand corner there. So this way you have small pebbles that form a beach. Okay, so those are just some of the examples of coastal habitats that we can see in the UK. What we're going to look at next is the anatomy of the coastline. So the coastline in any coastline really is made up of a number of different areas and sections. If we start on the left hand side, we can see cliffs and the beach, and this is where the bedrock and the land mass tends to be, and this is where we don't tend to find any water, but we may find important plant and animal species that are linked to the coastal habitat. So, for example, birds may nest on the cliffs. We then have the backshore. So the backshore is where essentially water doesn't touch this area generally. You might get some spray, but generally the tides don't go as high as this. We then have the foreshore, and the foreshore is when the tides go out, you have an exposed area. So this is a kind of subtidal area, which is sometimes covered by sea and sometimes not covered by the ocean. So you might find rock pools and things like that in this particular region. And then we have the near and the offshore. And the near and the offshore are two key areas where essentially the tides constantly cover these areas. So they're constantly covered by seawater. So they are distinct marine areas, and there'll be important species that live in these particular regions. Okay, so that's just the anatomy of the coastline. What we're going to do now is look at a case study. So what I want to look at is the White Cliffs of Dover, and really think about how and why they formed in the way that they are. So they're quite distinct white cliffs that are around 300 meters above sea level, which is quite high. And they're made of chalk, so we understand that the chalk is generally formed when remains of plankton and algae and things like that sink to the seabed and are layered up over millions and millions and millions of years and put under pressure by the sediments on top of it. And that forms this kind of soft rock as such. It's quite a soft rock compared to some others like granite, for example. Now, at some point in the last 70 million years, the seabed where this rock was formed was raised up, and it was raised up around the time that the Alps would have been forming in Italy. So as that kind of happened, it caused the UK as an island to be pushed up above sea level. And And then at some point around a few million years ago, the connection between Europe and the UK will have disappeared, and it would have led to this formation of these cliffs, which are now being eroded. And we're going to have a look at this process. Now, in 2015, there was a storm, Storm Imogen, and that hit the UK coast quite hard. And it uncovered some really interesting features. And we're going to have a quick look at one of these. So this circular crater is one that was uncovered in the east of England, in the southeast of England. And this, you can see, it's a perfectly circular crater. And archaeologists were really interested as to like what actually was it, because it's not natural. It's generally not something natural that's going to have formed this. It's probably something that's to do with a human who've used tools, and you can see the markings of the tools that have dug it out. So they looked back through the historical records, and what they found was this. So this image here, this was taken in 1976, and this is the same cliff. But this here, this line down the middle of the cliff is the remnants of an old Bronze Age well shaft. Now, this cliff is no longer here. So what you can see is where this cliff is at the moment, and that well shaft. If we go back to this image, this is where the cliff used to be in the 1970s. So they dug back a bit further, and when they dug back a bit further, they found this map here. And this is a map of the top of the cliff, and it shows an old Bronze Age kind of settlement as such. And right in the middle of this particular settlement is a pit, and that pit is the well. And what you can see is it's a good couple of meters away from the edge of the cliff in the early 1900s. So this shows essentially how much the cliff has receded by. And the cliff now is probably up where this footpath is at the top of the image. So the cliff has receded some 30, 40, 50 meters away from where it is now. And what we are interested in at this point is how has the cliff receded this far so quickly? And when we start to look at this, there are some really key factors, and there are 6 major factors that actually lead to the receding of this particular area of the UK. Let's have a quick look at these particular factors. So the first is the fact that we have soft chalk headland, and so the bedrock is chalk, and it's quite a soft rock. You can generally break chalk up with your fingers. It's quite soft in that sense compared to other rocks. So if you imagine you can do that to the rock with your fingers, think about the damage that waves and like strong storms could do to that particular type of rock. Now we call this particular action hydraulic action. So when the waves smash against the base of the cliff, it causes hydraulic action, and this leads to abrasion. And abrasion digs away essentially at the base of the cliff, and you get what's called a notch forming. And I'll show you a notch in a minute. Now at the same time, as the base of the cliff is being ripped away by the waves, the top of the cliff is being attacked by weather elements. So rain, for example, rain seeping into the small cracks in the top of the cliff. And as the rain seeps into these cracks, it causes erosion very slowly. Sometimes this rainwater also freezes. Now, when water freezes, it expands, and as it expands, it creates larger cracks in the rock. At the same time, well, not at the same time, in the summer, the rocks are south-facing. They're exposed to heat all throughout the day, and the rocks expand as they heat up, and they crack further. So these cracks form through the summer months, and then we enter into autumn, and we generally then get storms. And when storms come, they bring high winds, large waves, and these dislodge any loose rocks that fall, sometimes en masse. You get big cliff falls, landslides that fall onto the beach below. And this leads to huge erosion of this particular area. What I've done for you at this point is I've put together this particular image. This is on the Google site if you do want to get a copy of it. It just shows all of those elements acting upon that particular habitat. So you can see the waves at the base of the cliff. They are attacking the base of the cliff, and I'll show you the wave cut platform and how it forms in a minute. And then you've got the wind, precipitation, and the heat acting upon this cliff, causing the top of the cliff to fall onto the base below. Now, this leads to this particular situation, to where we get a wave cut platform forming. And what you can see here on the left-hand side is a wave cut notch. So this is where the waves come in and they hit the base of the cliff, and over time they cause this notch to form in the wave attack zone. And this leaves the cliff top above it very unstable. And occasionally, obviously, when you get the right elements acting upon the cliff will fall onto the wave cut platform below. And this can lead to boulders and kind of other kind of rocks that sit on this wave cut platform. And those boulders can then hit against the cliff face at the bottom when waves come in. So this leads to essentially cliff erosion and wave cut platform formation. So we get the creation of a wave cut platform, we get the destruction of a cliff. And that's generally what we tend to find in all examples of physical processes on coastal habitats, is that you generally, where you get the destruction of something, you get the creation of something else. So it's very easy to find examples of this, and that's what you're going to need to do for your assignment. Now, what geologists have actually found is that Beachy Head and that area around the east coast of the UK is eroding at about 22 to 32 centimetres a year. So that isn't a lot necessarily for a year, but if you add that up over decades, 10, 20, 30 years, that starts to add up into metres, and that's how quickly this particular area is eroding over and over and over. And what I'd like to do before the next video, which I'm going to release next week, is have a look at this particular slide here. Okay, so you can pause that and take note of what I'm asking you to do. So I'm asking you to describe the following words, which are all to do with erosion and physical processes. And I want you to find images to back up your descriptions. So there's about 11 images there. I'd like you to try and to find images and descriptions to fit these particular words. And then what I'll do in the next video is I'll go through each of these processes and I'll give you examples of where we find them and how they interact with the coastal habitats. Okay, so until next time, have a good week, and I'll see you next.